Hello students. Okay, I did an example of how you can find the stationary points of a function and then use the second derivative test to determine their nature. So what I'd like you to do now is to pause this video, and have a go yourself for this particular function. Go through all the steps and then come back and check your answer. Okay, let's go through the solution to this one. So step number one, find the derivative of the function. So that's what you come up with. Double check that you got that correct. Step number two, set it equal to 0, solve for x. So there's set equal to 0. Notice once again with this function here, we can divide out the common factor of 6, which gives us a much easier equation to solve, and factorize it. And from that, we know that the turning points have an x-coordinate of -1 or an x-coordinate of +2. Okay, moving on to step 3. We're going to use the second derivative test to decide if each of those points is a max, min, or point of horizontal inflection. So first we find the second derivative, so you should have come up with that. Sub in our first x-coordinate of -1. That comes out to be the second derivative, evaluates to be -18. Because it's a negative number, we know that there's a maximum at x equals -1. Okay, second thing we do is we put in the second x-coordinate of a turning point, which is 2. Evaluate that, we get +18, and that tells us that at +18, because it's positive, we must have a minimum at that point. And finally, we got to then work out the y-coordinates of that. So the y-coordinates of the turning points for, there's the function just there. So when x is -1, y is 0. So we find out that -1, 0 is a max. And when x equals 2, the value of the function is -27. And therefore, the minimum is at 2, -27. Okay, and one last thing before we move on to optimization is let's just have a look and see what happens if we do a first derivative test and made a graph that looks like that. So there's obviously at x equals 0, we've got a stationary point because the derivative is 0. When we do the first derivative test, we get a graph going down, horizontal and down. And hopefully you understand that that basically means we must have a point of horizontal inflection at this particular point. So that's what the graph would look like. You could also get one that started low, came up, and went up. And that would be a positive there, 0 there, and positive there. So that's just what that would look like for the first derivative test. So hiding under my little box here this is a point of horizontal inflection. Okay, we have one last video to go, which is optimization.